All right, this is Mr. Peterson with another screencast for AP Environmental Science. Today, we're learning about water. Water is one of the most important resources on Earth because it is essential to have for survival. It's also important indirectly because it is needed to grow food and lumber. It's also important for moderating the Earth's climate and for removing and diluting the waste we generate. Now, because water exists as one of the natural cycles on Earth, the amount of water on Earth doesn't really change. A molecule of water may evaporate one day, condense as rain the next, and then run off and collect in the ocean later. But it's always on Earth. The problem concerning water is availability, like the famous poem about the albatross. On Earth, there's water everywhere, but not a drop to drink. Only 0.024% of the water on Earth is available as liquid freshwater. The other 99.976% is either salty water in the ocean, frozen as ice, or buried so deep underground that we can't access it. So that's one part of the availability problem. Not much of it is usable. The other part is the water cycle continually refreshes the available water and purifies it, but only if we don't overload. Wells that are overpumped can go dry. Rainfall patterns can shift due to clearing vegetation, climate change, and other man-made causes. It's an availability problem if the water is on Earth, but not in the places where we want to be. Now, some terms we need to learn about sources of water. First up is groundwater. This is water that has infiltrated the ground so far that it's become trapped in layers of permeable rock. Some rock materials are impermeable to water, so the water can pass through them, and so they're trapped in permeable rock formations that have microscopic holes that allow water to enter and exit. This layer of rock that holds the water is called the zone of saturation, and the top level of this zone is the water table. In times of high rainfall, the water table can rise, and in times of drought, it falls. If you've ever been to the beach and dug a hole in the sand and watched the water fill in from the bottom, that's the water table you're seeing. You just removed the sand that was covering it up. Aquifers are layers of rock deeper underground that contain groundwater. Natural recharge occurs when rainfall moves downward through the soil to refill the aquifer. Lateral recharge occurs when water infiltrates from other areas and moves underground through the aquifer to another location, normally like flowing downhill. Surface water, on the other hand, is any fresh water that collects in rivers, streams, lakes, and wetlands. It collects by runoff from precipitation and melting snow or ice. A watershed is the entire land area that the water runs off from to collect into a body of water. It's also called a drainage basin. So a watershed is an area of land that drains all of the streams and rainfall to a common outlet. Characteristics of a given watershed include its area, length, slope, soil, vegetation types, and divides with adjoining watersheds. This is the Mississippi River watershed. You can see all of these smaller streams all flowing into it, and they all dump into the Gulf near New Orleans, Louisiana. This is the world's third largest watershed. Water shortages threaten human existence, and they happen for many different reasons. The main ones are dry climates, drought, too many people using a water supply, and wasteful use of water. 783 million people do not have access to clean water. There are a lot of examples of water shortages and reasons in your book, and you should read through and be familiar with them. For the rest of this unit, we'll focus on ways to address water shortages, mostly by increasing the water supply. First up is extracting groundwater. By drilling new wells or pumping the existing ones more, we can increase the amount of water we have available to use. The problem is we haven't increased the supply of water. It's still the same. If you look at this picture in the area around the well, the water table has moved downward because the water has been pumped above the ground. It takes time for the water nearby to move into that area, so in the meantime, the water table has fallen downward. Natural and lateral recharge will replace the water over time, but typically the water is pumped out faster than the recharge can take place. That can lead to aquifer depletion, where wells can go dry because the water table has moved further down than the depth of the well. Wells can be extended downward, but the cost of that water increases because the increased depth and energy used to pump the water up. Another negative effect of pumping groundwater is subsidence. The areas of sand and rock that normally hold water can collapse when dry. Sinkholes are a form of subsidence that happen. Another negative effect of pumping groundwater is this subsidence. It's the areas of sand and rock that normally hold water can collapse, and when dry, sinkholes will form just like seen here. It's an extreme example of a sinkhole, one that opened up in Guatemala in 2010, and it's really scary looking. Saltwater intrusion is another problem. As fresh water is pumped up a well, salt water that would normally only infiltrate a short distance underground is pulled into that space left behind by the fresh water. Wells that are overpumped can start to pull up water that is partially salty, which renders that well useless. So pumping more groundwater to increase the available supply isn't a really great answer for water scarcity. Next up is building dams. If the water is going towards the ocean, where we can't use it as easily, why not stop it? A dam is any structure that alters the flow of water through a river, and the lake that develops above the dam is called a reservoir. The advantages of a dam include collecting runoff water and storing it for later use for humans to use, generating electricity, and flood control. Reservoirs also provide a lot of recreational activities. The downsides are that dams flood areas once they're built, so people living where the reservoir is will have to move. Dams also harm many species of fish because they can't move freely through the dam. Also, the life of a dam is limited because the reservoir will fill over time with sediment as the water sits and materials settle to the bottom. So dams aren't a perfect solution either. Next up is transferring water from one place to another. Maybe that can solve problems of water scarcity. And the picture is an aqueduct from ancient Rome. And the top layer of rock is a channel that carries the water from point A to point B. In more modern times, we'd use pipes or tunnels to carry the water, but this is ancient Rome, and it's pretty impressive. The advantage of this strategy is pretty obvious. We can move water from a water-rich area to a water-poor area. The disadvantage is that removing the water from the source can alter the environment in that area. Less fresh water flowing in the rivers can affect wildlife, and less fresh water flowing in the ocean can make the coastal water saltier. An issue affecting the oyster populations of Apalachicola Bay right now. Okay. So none of these strategies are great. Maybe using salt water to make fresh water is a solution. It's totally possible, and there's some countries doing it right now through a process called desalination. The salt is removed from water, making it fresh water. Salt water can be boiled, and the steam is collected and condensed as pure water, while the salts are left behind. That's called distilled water. The kind you buy in the grocery store is just normal fresh water that's been boiled and condensed to remove any impurities, but it's done with salt water in areas of the world that have very little fresh water, think Middle East. Reverse osmosis involves pushing salt water through a series of very fine filters that removes the salt. Countries in the Middle East use both methods to generate fresh water. The advantage is obvious. You've made fresh water where there wasn't any, so that helps address water scarcity. The disadvantage is that the process requires large amounts of energy to boil the water or to push it through the filters. Plus, the leftover salt has to go somewhere, so it ends up affecting aquatic life when it's dumped back into the ocean and increases the salinity of the water. None of these previous ideas are real solutions to the problem of water scarcity. Instead, the better solution is to find ways to use water more sustainably. After all, the water cycle will replenish fresh water over time, so if we can find ways to use it more wisely, we'll never run out. One of the big ways to use less water is to reduce evaporation. It sounds strange, but when you consider how much fresh water is used to grow plants in agriculture, it makes sense. The largest use of fresh water is for irrigation, about 70% of all water used. If you used a sprinkler to spray water onto all of these plants, a huge percentage of that water would evaporate in the air before it even hit the ground. Most of the water hitting the ground wouldn't hit the plants directly and would evaporate before the plants could absorb it or would just run off. So, to address the problem, each plant in this picture has its own pipe that delivers water to it directly, just where it's needed. Several types of irrigation include drip irrigation, pictured before, flood irrigation, which is the practice of flooding land with amazing amounts of water to grow crops, like the picture on the right, and furrow irrigation, like the picture on the left, where we flood in channels. On a larger scale, here's a center pivot irrigation rig, modified so that it doesn't spray water up into the air from the top, but instead it sprays water from just a few feet above the ground. This is a type of irrigation called spray irrigation. Since the water spends less time in the air, it evaporates less. Less evaporation equals less water is used to get to the same amount of crops grown. So that helps address water scarcity. It's a win-win because while the equipment modifications cost money, they make that back quickly and decreased water cost. Now, here's the Ogallala Aquifer in the U.S. Sorry if that's mispronounced. This aquifer supplies about 1/3 of all the groundwater used in the U.S. and made the Great Plains one of the world's most productive agricultural regions. Bad soil management and a drought led to the Dust Bowl in the region in the 1930s. Better soil conservation and irrigation techniques has corrected this issue, but well outputs and droughts have recently brought back Dust Bowl style storms, according to climate.gov, and it depends year to year. Plus, this aquifer is being depleted, even though it's one of the largest aquifers in the world. Next up is sustainable water use and is reducing leaks. Nearly half of the water used in major cities is lost to leaks. This may not be through leaks from your faucet like the picture, but it may be from slow leaks in your toilet and in underground water pipes, which you'll never see until they burst. The water pipes in your yard are buried a few feet deep, so you're likely not notice if one of them sprung a leak after part of your yard becomes, unless part of your yard becomes a wetland. But the larger water mains that deliver water throughout the city can be buried over 5 or 6 feet deep. So water leaks from those pipes are often never detected until it's much, much too late. One way to reduce water waste is to increase the price of water. That hits everyone in the pocketbook, and it hits poor people and farmers the hardest. So it's not a real great way to reduce waste. Government subsidies are a better solution, and it works when the government makes payments to an individual, a farm, or a utility company that has taken steps to reduce water waste. This, in my mind, is a perfect role for the government. Another method is to reduce water wasted in irrigation, something I've already mentioned. Water waste can also be reduced in industry when water that is part of a production process is recycled or reused, instead of using new water from somewhere else. Last up is reducing water waste in homes. Two of the biggest uses of water in the home are showers and toilets. Most shower heads have improved over the past few decades to the point where it's industry standard, because of federal law, now to produce shower heads that only allow 2.5 gallons of water per minute. Look at your shower head sometime. Somewhere on it, it should have the letters 2.5 gallons per minute printed on it. If not, it's likely to be so old that it was made before the law changed and it's probably uses much more than 2.5 gallons per minute, unless you have multiple shower heads in your shower. The other big source of water waste in home is toilets. Newer toilets being made today have gone through major changes to use less water per flush. The first low-flow toilets were heavily criticized because in an effort to reduce water use, they ended up not being able to flush bigger things. More modern low-flow toilets include valves that can change how much water they use depending on how much flushing needs to be done, like pictured here. The one on the right would be, let's say you went for a small job, number one. The one on the left would be for larger jobs that needed more water to flush waste. In the end, water is being conserved because you don't often need the bigger flush. One final way to reduce water loss in the home is landscaping. This is an example of a home that's been landscaped, but it's called xeriscaping because it uses very little water to maintain it. There are plantings of flowers and trees, but they've been selected for their low water requirements. And last up are areas that face the opposite of water scarcity. These areas receive too much water at times. Floods occur when water in streams overflow normal channel and covers the area nearby, an area called the floodplain. Human activities increase flooding because when vegetation near the river and the floodplain is removed, the water can move faster and cause more damage downstream. The floodplain areas are often wetlands, which are often cleared and drained for development. If the development wasn't there, then the flood wouldn't be a problem. Last up, global climate change has altered weather patterns, increasing precipitation in some areas over time, which leads to more flooding. There are many strategies to reduce flood risks, including levees and dams, but most of these have failed miserably. The best strategy is to leave the wetlands and floodplains intact so they can flood naturally without causing damage to human development. And that's it for this screencast. Thanks for watching.